Viewers, welcome to yet another tutorial with the Magician. Learners, this is your favorite channel. Hit the subscribe button so that you can get any updates from the channel. Share, comment and suggest which sections you need assistance with. We will make the video just for you. In response to a learner who requested arrangements, permutations and combinations, this tutorial walks you through the topic. Each example is meant to teach and cement your knowledge on the section. Just some basics before we start. Right, if you are arranging n objects in a line, it's n factorial. If there are any repeats, you divide by the repeats. We're also going to look at how to use the permute function, how to use the choose function. Basically, you permute if order is important. You choose if order is not important. So enjoy.
Right here, so what we are doing is we're doing questions from past papers on permutations and combinations. Right, our question here is on arrangements. We are given the digits 1, 2, 2, 3, 6, 7, 8, and you want to arrange to form a 7-digit number here. How many 7-digit numbers can be made? So number one, there are no restrictions. There are 7 numbers, so I'm going to go 7 factorial divided by the repeats. The 2's repeat, so 2 factorial for the repeats. If I do that on my calculator, I get 2520. Right, so this is my first part. Number 2, the digits 1, 3, 7 are next to each other. Right, so I'm going to put on my 7 spaces, 1, 2, 3, 4, 5, 6, 7. Right, and then I'm going to go, I want the 1, the 3 and the 7 to be next to each other. The other digits are, I've got a 2, a 2, a 6 and an 8. Right, so these are, I bundle them because I want them to be together. So I've got all in all 1, 2, 3, 4, 5. So I'm going to go 5 factorial. But you see these 2's repeat, so I'm going to divide by 2 factorial for those repeats. But these bundled also can interchange in 3 factorial ways. Right, so if you do that on your calculator, you see that you get 360. Right, part 3 says the 7 digit numbers are even. For you to have an even number, remember you have to end on an even number. So our even numbers are 2, 6 and 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to either end with the 2, or I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to end in a 6, or 1, 2, 3, 4, 5, 6, 7. I'm going to end in an 8. So we have those 3 scenarios there. We're going to look at these case by case. Right, so the first case, if I end with 2, I've got the digits 1, 2, 3, 6, 7 and 8. Now, so these are 6 numbers, so 6 factorial. There are no repeats, yes, so I'm going to do that on my calculator. I get 720. Right, so that's for the first case. The second case, if I use up the 6 there, I will have 1, 2, 2, 3, 7 and 8. I've used the 6. Now this is going to be 6 numbers. That's 6 factorial over 2 factorial, which is 360. Right, the second case, now I've used the 8, so I have 1, 2, 2, 3, 6, 7. So this is 6 factorial, but again the 2's repeat, and this gives 360. Since these 3 are different options of the same thing, I'm going to add them up. So 720 plus 360 plus 360, and my final solution there is 1440. Right, so this is how I do that question there. Right, next question here, I'm given the word Argentina there. It includes 4 consonants. So if I'm to put my consonants here, I've got for my consonants, I've got R, I've got G, I've got N, I've got an N again, and I've got T. So these are my consonants. If I put the vowels together, I've got A, I've got A, I've got E, I've got I. So those are my consonants. Right. Now part 1. Find the number of different arrangements using the 9 letters. Alright, there are no restrictions. 9 factorial. Are they repeats? Right. Yes, they are repeats. I can see there my n's repeat, so 2 factorial for the n's repeating. Any other repeats? Yes, the a's repeat, 2 factorial for the a's that repeat there. If I do that on my calculator, I get 90720. Right. So this is part 1. There are no restrictions. Part 2. How many of these arrangements have a consonant at the beginning, vowel, then a consonant, then a vowel? So I'm going to put, I've got how many letters altogether? So I've got 2, 4, 5, 9 letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to have a consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonants. Right. So for me to do that, I'm going to arrange the consonants first. So these, I'm going to see how many ways of me arranging these consonants here. And I've seen that I've got these 5 consonants. So 5 factorial for arranging the consonants, or the ends repeat divided by 2 factorial. I'm going to do the vowels. I've got 4 vowels, 4 factorial, but the A's repeat, so over 2 factorial. And if I do that on my calculator, I get 720. Right. So this is basically how I do the question there. Right, my next question there is, I've got the 6 digits 4, 5, 6, 7, 7, 7 can be arranged to give many different 6-digit numbers. Right, so I'm going to go part 1. So for part 1, how many different 6-digit numbers can be made? So there are no restrictions here. 6 factorial. Right, now the 7s repeat, so over 3 factorial, and I see on my calculator here I get 120. Right, part 2. Right, how many of these 6-digit numbers will start with an odd and end with an odd? Now my odd numbers, I've got 5, I've got 7, 7, and 7. So 1, 2, 3, 4, 5, 6. So I can either have 5 here and 7, or again 1, 2, 3, 4, 5, 6. I can have 7 and 5 here, or I can have 1, 2, 3, 4, 5, 6. Remember, I've got 3 7s, so I can go 7 and 7. So I'm going to look at each case separately here. Right, so if I'm going to use up the 5 at the beginning and the 7 there, it means I'm left with 4, I'm left with 6, I'm left with the 2 7s here. So how many ways can I arrange those in the 4 spaces there? That's 4 factorial, but you can see the 7s repeat, so over 2 factorial. And if I do that on my calculator there, I get 12. Alright, I'm going to go to the next scenario there. It's almost the same as the first one again, because I'm left with these digits anyway. So I'm going to have 4 factorial again over 2 factorial, which is equal to 12 again. Right, the last part here now. So in my last part, I've used the 2 7s, so it means I'm left with 4, I'm left with 5, I'm left with 6, I'm left with 7. So this is just going to be 4 factorial. There are no repeats here. Right, so this gives 24. Right, and again, since these are different options, I'm using or here, the or rule, remember, for mutually exclusive. So I'm going to go 12 plus 12 plus 24, and I get my total as 48. So this is how I do that question there. Right, in my next question there, now, so part 1, a committee of 5 people is to be chosen. So just take note here, I've got 5 people which I need to choose, so I underline here, I need to choose 5. And this is, I'm choosing here from 6 men and 4 women. Alright, so I underline the keywords there. The committee of 5 people is to be chosen from 6 men and 4 women. In how many ways can this be done if there must be 3 men? So I need 3 men, so I'm going to go from the 6 men, I'm going to choose 3. Multiply by 4 women. From the 4 women, I'm going to choose 2. And if I do that on my calculator there, I see that I get 120. Right, now you may ask why I didn't permute and why I'm using choose. Now you need to end up having 3 men. If I choose A, B, C, and if I choose C, B, A, I end up with the same number of people here, the same type of people, in other words, same group of people. So the order here is not important, so I'm going to choose. Remember, when order is important, I would permute, but here order is not important. If I go A, B, C and I go C, B, A, it's basically the same group of people, so order is not important here. All right, so I'm going to choose. Right, part 2. If there must be more men than, so you need the number of men to be greater than the number of women here. So I'm going to look at choices here. I need 5. So either I've got 5 and I've got 0 here, or I've got 4 and I've got 1 here, or I've got 3 and I've got 2 here. So these are the options that I have. So I'm going to put a line here to divide my options, and then I'll start doing them one by one. All right, so I'll start. I need 5 men, but I have got 6, so I go 6, choose 5 by, I don't need any women, of course I can go 6, choose 0. Right, I need 4 men, so I'm going to go 6, choose 4 by, I need 1 woman, so I'm going to go 4, choose 1. So I will be getting all these answers here. Right, and then finally I need 3 men, so 6, choose 3 times, I need 2 women, so 4, choose 2, and I'll get that. And since I'm going this or that again, I'm going to add them up. So if you do each of those 3 cases and adding them up, you will see that on your calculator you get 186. So all these will give 186, because each of them, like the first one gives 6, so this will give 6. The second one would give 60, so this will give 60. The third one would give 120. So I have got 186. All right, part 3. So my part 3 here, if there must be 3 men and 2 women. Right, so I'm told, so I underline again my keywords. I need 3 men and 2 women, but one particular woman refuses to be in the committee with one particular man. Consider your choices here. Right, so I can put the men in and that woman out, so that's my first choice. Or I can go the woman in and the man out, or I can go both of them out, so both out. Right, so I've got these cases here. Right, I'm going to do these cases separately, so I'm going to divide here and then do the cases separately. Right, so this first case here and that case here and that case there. All right, so the final case here, which is that one. Right, so how am I going to do it? I want the men in. Right, there must be 3 men. There must be, so I need to choose 3 men here. There must be 2 women. I need to choose 2 women here. All right, now let's understand what we're doing here. If the man is in, it means already I've got that man in here, so I've got one person here already. So it means I have to choose 2. So I'm going to go choose 2. Right, so I'm going to choose 2 men here, but the number of men, I don't have 6 anymore because this I've put 1 already. So I'm going to go 5, choose 2. So I've chosen the men now. Times, I need the woman to be out, so I've got 3 women left now. If I've got 3 women left, I'm going to go 3, choose 2. Right. So that's for the first case here. The second case is if the woman is in. Alright. If the woman is in, that's a different scenario again here. So I'm going to go, I need 3 men and 2 women. So again, 1, 2, 3, 1, 2. Now the woman is in. So I've got 1 woman in here already. Right. So it means I have to choose 1 woman because the other woman is there. So I'm going to go choose 1. Right. But how many women do I have now? I had 4. I've used 1, so that's going to be 3. Let me write it on the appropriate space here. So this is going to be choose 1, and we no longer have 4 women, we have 3 women. So 3, choose 1. Now the man is out, so I've got 5 men here. So 5 men, I'm going to choose all 3. So this is the second scenario here. Right. The third scenario is when they're both out. So I'm going to consider when both of them are out. Right. So what do I have here? I need 3 men here. So 1, 2, 3. I need 2 women here. So 1, 2. If both of them are out, it means I've got 5 men. So I'm going to go 5, but I'm going to choose 3. If the woman is out again, I've got 3 women. I'm going to choose 2. Right. Now, if I do that on my calculator there, I'm going to end up with 90. So my final solution there is 90. So for that, I'll put it there. So the final here is 90. That is, if I add the first one, which is my 5 choose 3 times 3 choose 2, I get 30. So this first one there, I get 30. So the first one here, I get 30. If I go 5 choose 3 times 3 choose 1, I get 30 again. So this one here, I get 30 as well. If I go 5 choose 3 times 3 choose 2, I get 30 again. So that's where I'm getting my 90 as my final solution. So this 90 is for the final solution. So what the third part looks complicated here, but in actual fact, put down all your combinations. A certain woman says, I don't want to be in the committee with this man. So what do? Either the man is in and the woman is out, or the woman is in and the man is out, or both of them are out. This covers all the possibilities that you can have, and this simplifies the question, so it's now less complicated than it was when you're just reading off the question there. My next question there, a collection of 18 books contains 1 Harry Potter book. Linda is going to choose 6 of these books to take for holiday. Right. So I'm going to go part 1 here of this is of A. How many ways can she choose the 6 books? This is just choosing 6 books out of the 18. So I'm going to go, this is 18, choose 6. Right. And if I go 18, choose 6 on my calculator, I get 18,564. Right. 18,564. So this is for the part 1. Right. Part 2. How many of these books will include the Harry Potter book? Now remember, you're going to choose 6. So 1, 2, 3, 4, 5, 6. For you to be sure that you have the Harry Potter book, you have to put it here. So I've got 1 book, which is the Harry Potter here already. Right. So I've got 1, 2, 3, 4, 5. So I'm going to choose 5 books now. But I'm choosing 5 books from how many? I had 18 now. The Harry Potter book is gone. So 17. So my final solution is 17 choose 5. 17 choose 5 on your calculator is 6188. Right. So 6188. Alright. So what with this question, you want the Harry Potter book to be on your choices. So you put the book there already. You don't choose the Harry Potter book. You take the Harry Potter book, you put the book there. So it means that you have 5 books to choose. Right. So you need to pick 5 books, but from not from 18, because you have used the Harry Potter book, so it's from 17. Alright. Now part B. So part B there. B part 1. In how many ways can 5 boys and 3 girls stand in line if there are no restrictions? Oh, there are no restrictions, it's just 8 factorial. I know you'll be tempted to say over 5 factorial and 3 factorial. Those are not repeats, they are people, they are different people here. Alright, so there is just going to be 8 factorial, and if you do that, you get 40,320. I stress again, you don't divide by the repeats because those are not repeats, they are people, they are different. Right. If the boys stand next to each other, so 1 2 3 4 5 6 7 8, so I've got 5 boys. So the first boy here, the second boy, the third boy, the fourth boy, and then the fifth boy here. And then I've got 3 girls, so the first girl, the second girl, the third girl. Right, but I'm told I need the boys to be next to each other, so my boys here, these will move as one. So whenever you need things to be together, group them. So this will move as 1, then you have got 2, and then 3, and then 4. So basically this is 4 factorial, right? Times, because remember, the next thing to remember, don't forget these bundled items can shuffle 5 factorial ways because there are 5 items here. Then there's nothing which is the same here, so you don't divide by anything, and your final solution would be 2880. Right, these are people, so you don't divide, there are no repeats. My next question there, a football team consists of 3 players who play in the defense. Right, so I've underlined the keywords: 3 defense players, 3 players in the midfield, I've got 5 players in the forward position. Alright, 3 players are to be chosen, so I've got 1 2 3, I need 3 there. Right, in how many ways this can be done if the captain, who is a midfield, so I'm going to go midfield 1, so this is the captain here, right, must be included. So I've included the captain. I don't choose the captain because this is an individual person. I know the captain, so I'm not going to choose the captain together with 1 defense. So I need to choose a defense here. I've got 3 defense, so for part 1 I'm going to go 3 choose 1 for the defense, and I need to choose 1 forward, so this is a forward player. I've got 5 forward players, so 5 choose 1. Right, if I do that on my calculator, I get 15. Right, so this is for part 1. Right, A part 2. So for A part 2, the question here is if exactly 1 forward player must be included. So 1 2 3, 1 forward player, I need that forward player there. Right, I've got 5 forward players, so I'm going to go 5 choose 1. Right, so I'm not going to choose any other forward player because I need exactly, so that's the word, exactly 1. So exactly 1 has been chosen. I'm left with 3 defense, 3 midfielders, so I'm left with 6 players. So 6, I'm going to choose 2 because any of those can occupy these 2 positions. Right, so if I do that on my calculator, I get this as 75. Alright, then part B now. For part B, so B part 1, how many different arrangements are there for the 9 letters of the word gold medal if there are no restrictions? Okay, so that's going to be 9 factorial. Are there any repeats here? Let me check. Yes, there are repeats. There are repeats for the D's, so 2 factorial for the D's. There are repeats for the L's, so 2 factorial for the L's. Right, if I do that on my calculator, I see I get 90720. Right, part 2, if the 2 D's come first and the 2 L's come last, now there are 9 letters, so I'm going to go 9 spaces, 1 2 3 4 5 6 7 8 9. I need the 2 D's to come first, so I put the D's here, and the 2 L's to come last. If I do that, it means I'm left with G, I'm left with O, I'm left with, I've used an L, I've used a D, I'm left with M, I'm left with E, I'm left with, I've used the D, I'm left with A. Yes, and that's it. So those will fit in these spaces, 1 2 3 4 5. Right, so I'm going to go, this is 5 factorial. Right, yes, there are no repeats because I've used the D's and the L's. So 5 factorial there, which is 120. So this is for this part here. Right, so that's how you do that question there. Right, in my next question, the diagram shows the seating plan for passengers in a minibus, which has 16 seats arranged in 4 rows. Right, the back row has 5 seats. Right, and the other 3 rows have 2 seats in each side. 11 passengers get into the minibus. So my key point there is 11 passengers get into the minibus. So I underline my 11 here. Right, part 1. How many possible seating arrangements are there for the 11 passengers? Now remember, seating arrangement you permute, because the way you sit, if you swap positions, order matters. So seating arrangement is permuting. So I know I'm going to go 7 permute my 11 here. All right. So that's going to be my part 1. If I go 7 permute 11, I get a big number, but yes, that's the one we want. 494 010 316 800. Don't be worried if you get these big numbers. It's very possible for questions of permutations or combinations to get these big numbers. Right. Part 2. How many possible seating arrangements if 5 particular people sit at the back? So 5 go and sit here. There are 5 seats and 5 people. Alright? So those 5 people can shuffle 5 factorial ways. So I've arranged the back seat. So the back seat here, 5 factorial ways. Alright. Times. Now I had 11 passengers. 11 minus those 5 at the back. So 11 minus 5, I've got 6. Right. Now, out of the 17 seats, I'm going to go 17 minus, I've used the 5. So that's going to be 12. So this is 12 permute. How many passengers? 6. So 5 factorial times. So 5 factorial is for the back seat. Then the remaining is 12 permute 6. Right. If you do that on your calculator, again, you get a number which is big. 79833 600. Alright, now we go on to the next question. Of the 11 passengers, 5 are unmarried and 6 consist of, so I'm going to write my information here. So 5 unmarried here, right? So 5 are unmarried. The other 6 consist of 3 married couples. So either you can have A, B, you can have C, D, you can have E, F. So say these are your married couples, right? So the first couple, the second, and the third, right? Part 3. So part 3 here. In how many ways can 5 of the passengers on the bus be chosen? So you want to choose 5. 1, 2, 3, 4, 5. If there must be 2 married couples, okay, so out of the couples, you need to choose 2 couples. There are 3 couples, I choose 2. It means I've filled in 4 spots here, because if I choose 2 couples, it means that's 4 people. Say I choose that couple and that couple, it means this couple is not chosen here. Right. Now, I've spaced for one other gap here which I want to fill in. Right. There must be 2 married couples. I've done that. One other person who may or may not be married. So it's not necessarily this person from the 5 unmarried here. It can be these 2 who are left behind. So I add the 2 and the 5. So I get 7 now. Right. So I'm adding the unmarried to the ones I didn't choose. So times the 7, I'm going to choose 1 here. Right. So if I do that on my calculator, I get 21. So see how I do it. I do my married couples first. Those who are not chosen, the 2 will add to the 5 unmarried, and I have 7, then I choose 1. Alright, so this is how you do this kind of question here. My next question. 6 men and 3 women are standing in a supermarket queue. Right, so again, I highlight my important things. 6 men and 3 women. Right. Part 1. How many possible arrangements are there if there are no restrictions to the order? Alright, no restriction, 9 factorial, because I'm going to add. Again, don't divide, don't be tempted to say over 6 factorial, 3 factorial. Those are people, they are not repeats. Alright, so this is going to be my part 1 here. Of course, you can finish that on your calculator. Right, part 2. Right, now my part 2 here is how many possible arrangements are there if no two of the women are standing next to each other. No two of the women are standing next to each other. Right, so I find it easy to fit in to do the men first, leaving gaps. So I'm going to go 1, 2, 3, 4, 5, 6. So I go the first man, the second man, the third man, the fourth man, the fifth man, and then the sixth man here. These can be arranged in 6 factorial ways. Alright, so I do the men. But after I do the men, I have left gaps in between which I can fit in the women here. So these gaps can fit in the women. Right. So I'm going to go times here. There are 3 women which can fit in those positions here. So how many can that be done? 1, 2, 3, 4, 5, 6, 7 gaps. So 7, I'm going to permute the 3 women here. Right. So what did I do? I arranged the men, leaving gaps so that I can fit in the women, because I don't need any 2 women to be next to each other. So arrange the men, then fit in the woman on the spaces. Yeah, right. If you do that on your calculator, then you are going to get what we need there. So you can also do that on your calculator. Part 3. 3 of the people in the queue are chosen to take part in a customer survey. So you need 1, 2, 3. How many different choices are possible if at least 1 woman must be chosen? At least 1 woman. So woman, men. So you need at least 1. So either I can have all 3 and 0, or I can have 2 and 1, or 1 and then if I've got 1 there, it means I will have 2. Right. So there I have at least 1 woman. The first combination there, I've got 3 women. So the first is 3. I'm going to choose 3 by 6, choose 0. So this is for this first one here. The second one plus the second one is going to be, right, women I chose 2, so 3 choose 2 times 6 choose 1. Alright, I'm going to go plus, and then I do the last one. So this is going to be 3 choose 1 times 6 choose 2. So again, you do that on your calculator there. Alright, so particularly I want you to pay attention to part 2 there. Make sure you arrange the men first, leaving gaps, and then you would permute your women on the spaces left there. This is an important concept. Alright, my next question here. Find how many numbers between 5,000 and 6,000 that can be formed using the digits 1 to 6. Right. Part 1 says if no digits are repeated. So for it to be between 5,000 and 6,000, it must have 4 digits. That's what we notice first. It must start with 5. If it starts with 4 or anything less, it will be less than 5,000. If the number starts with 6, it will be more. So definitely it has to start with 5. If I start with 5, it means I've got these digits remaining. 1, 2, 3, 4, and 6. Right. So I'm going to use a different approach here. How many choices do I have for that space here? I've got 5 choices. How many choices do I have for the second spot? Now that I've used another number, so I've got 4 choices. How many choices do you have for the last digit there? I've got 3 choices. Take note, this is the same as going 5 permute 3. Right. You see in part 2 why I use this approach. If you do this on your calculator, you would see that you get 60. Right, so your part 1 is 60. Part 2. Right. So again, 1, 2, 3, 4, and I'm going to start with 5 again for it to be between 5,000 and 6,000. Now, if repeated digits are allowed, so it means I've got 1, 2, 3, 4. Take note, I'm using the 5 again because I can repeat it. How many choices do I have for here? There are 6 numbers, so 6. I can use the there's 6 choices again. I can use the number again, there's 6 choices here. So basically, if you do that, you get 6 to the power 3, which is 216. Alright, so you understand why I use that approach in part 1. We go to B, right? B part 1. Find the number of ways of choosing a school team of 5 pupils. Now, so I'm going to go here. I'm choosing 5, and this is from 6 boys and 8 girls. If there must be more girls than boys, so I'm going to go, the number of girls here must be greater than the number of boys. I'm choosing 5, so I can have 5, 0, or I can have 4, 1, or I can have 3 and 2. Right. If I've got, so girls, I've got 8. So I'm going to go 8, choose 5 times 6, choose 0. I'm going to go 8, choose 4 times 6, choose 1. I'm going to go 8, choose 3 times 6, choose 2. Alright, so these are my combinations where I have more girls than boys. And if I do that on my calculator, I get 56 here. For the second one, I get 420. For the third one, I get 840. And if I add there, because these are different options, I'm going or. So if I add, I get 1316 here. Alright, so this is for B part 1. Now I'm going to do B part 2 down here. So B part 2. If 3 of the boys are cousins and are either all in the team or all out of the team. So I'm choosing 5. So 1, 2, 3, 4, 5. Right. So I'm going to go all in. So the cousins, I'm going to go B1, B2, B3. Right. So those are the 3 cousins. Yeah. 3 of the boys who are cousins. If they're both in, so if they're all in, it means I have got spaces left for 2. All right. So space is left for 2, and it means if I take those 3 boys here, I'm left with 3 boys and I'm left with 8 girls. This question doesn't specify that I need girls here, so I can combine them. So I've got 11. So I've got 11. I want to choose the remaining 2. I combine them because I'm not specifying what I need here. Do I need girls or do I need a boy again? Right. Plus, so that's the all part. All not in, so all out. So all of them are out. That's the last one here. Right, so again, I'm going to go 1, 2, 3, 4, 5. If all of them are out, it means that I have removed those 3 boys because they're out. I'm left with 3 boys. I'm left with 8 girls. So I'm going to go 11 again. I'm going to choose 5 this time around because I'm choosing everyone. I don't have anyone in my selection. Right. If I do that, I've got 5, 1, 7. All right. So I hope you understood these examples, helped you understand the concepts of permutations and combinations and arrangements in a line.